Hello and welcome to all the viewers who are watching this online video. Today we are going to start a new topic which is for the student of class 9, and the subject is physics and the topic's name is sound. Now, to understand sound, I would suggest that first of all we must understand what is wave, because in general if you ask something that defines sound, you normally student used to give the answers that is the sound is a form of energy and it's a kind of wave which enables us to hear. But it's my being a physics person, I would suggest that first of all everyone should understand what is wave, how the wave moves, and etc. etc. So let's start with the term what is wave, right? So first of all, when we start with the wave, it's a common definition of the wave means it's something, a process through which the momentum and the energy is transferred from one point to another point without actually transportation of the medium. And the most common waveform with which we are very familiar is the waves which can be produced on the surface of the water. Just have a look over here, that when we throw, suppose this is a pond, and when we throw a stone in the pond, then we can see the ripples are moving in the form of concentric circles in ever expanding radii, and as it appears as if the water is flowing in the outward direction from the point of disturbance. Like suppose if I throw a stone at this point, this is the point where the disturbances start, and we can see that the waves, the ripples that produces are moving in the outward direction, and they are in the ever expanding radii till they expand, till they collide with the boundary of the pond. So it appears as for a person that water is actually flowing from in the outward direction from the point of disturbance. But if we place a simple cork on the disturbed water surface, we will find that the cork simply moves up and down, but it actually doesn't move in the outward direction. This proves that what we are actually feeling, that water is moving in the outside direction, it is not the case actually. Only we can say that, rather it's better to say that we have simply created the moving disturbances which are moving from the point of disturbances to the outward direction. And this is something we define as wave. In the same manner, when a drummer beats the drum, that same sound, since sound is a form of energy, that energy is transferred by the medium, it hits our diaphragm which is inside the ear, and that due to that vibration it enables us to hear. So this is something, the process how wave actually moves. But it appears as it's very easy to understand, or it's very easy to define wave, but it is not the case, because if someone want to understand very clearly that what is wave, we can understand how we can define it by the two basic properties of the material, that is inertia and elasticity. To understand the propagation of wave, let's consider one example. Say this is the smooth surface of water which is represented by xy, and let's assume we have a particle A at this point. When we drop some stone of mass m from a certain height and it comes down, it hits the particle A, and this stone has to do some work to take the particle A from this position to this position, and the new position is represented by point B. Now this work will be done due to the restoring force which is developed in the medium, and this is due to the elasticity as I have mentioned earlier. Now since this external agency has to do some work to take the particle from A to B, that work will be stored in the form of potential energy in the particle when it is at point B. And this is the sign of instability, because any object which has some certain amount of potential energy, this simply shows its instability. And this, due to this reason, the particle which is at point B now try to reduce its potential energy by converting its own potential energy into kinetic energy, and due to this reason this particle again start moving from B to point A. Now this is the right position where we can introduce the term inertia. As we all know that inertia is a very important property of mechanics. So due to inertia, when the particle start traveling from B to A, it will not stop at A, it will overshoot for this point and will move to a certain height, say B dash. And again, during this process, the potential energy, the kinetic energy is converted into potential energy. And this process will be repeatedly, continuously shown by these particles, and then this particle A will start moving up and down. This is the reason that particles of the medium start, when we create some disturbance, the particle of the medium start moving in the up and down motion. That's all. So in the today's session we have learned how the particle moves in up and down motion, and in the next session we'll learn how the wave propagate in the medium. Thank you.